a load of laundry and wonder, what's the actual chance I'll find all matching socks this time? Sigh. Or maybe you've tried to guess how many times your little sibling will actually listen to you today. Well, in our last video, we talked about theoretical probability, what should happen in a perfect world. But today, we're diving into the messy, fun, and super practical side of probability, experimental probability. This is all about what actually happens when you conduct an experiment, run a test, or just observe the world around you. Not all the time you'll be able to calculate the true probability of an event. For examples, the probability of the drive-through line at McDonald's being empty. This is where experimental probability comes in. So, what is it? Experimental probability is the probability of an event based on the results of an actual experiment or trial. It's simply the ratio of how many times an event occurred to the total number of times you tried it. Think of it as keeping a score during a game to see who's really winning. So you would record how many times you visit McDonald's and see a queue, and how many times you did not. This is super useful because real-world situations aren't always perfect like our math problems. Coins can be weighted, dice can be chipped, and sometimes those socks just vanish into another dimension. The formula for experimental probability is straightforward and easy to remember. It's like your personal scorecard for reality. Let's break it down. P, event. This just means the probability of a specific event. Number of times the event occurred. How many times did the thing you're looking for actually happen in your experiment? Total number of trials. How many times did you perform the experiment or make an observation in total? All right, for our first real-world experiment, we're going to use a thumbtack. If you drop a thumbtack, it can land in one of two ways, either with the point up or with the point down. Theoretically, it's tough to say exactly, but experimentally, we can find out. Let's drop this tack 20 times and record our results. Here we go. Okay, after 20 drops, here's what we got. Point up 12 times, point down 8 times. Now let's calculate the experimental probability of the tack landing point up. P, point up. Total number of drops. Number of point up results over total number of drops equals 12 divided by 20, 3/5. 0.6. So based on our experiment, there's a 0.6 or 60% experimental probability that the thumbtack lands point up. And for point down, 8 over 20, which is equal to 2/5 or 0.4. That's a 0.4 or 40% experimental probability for point down. See how what actually happened gives us a unique insight? So why bother with all these experiments when theoretical probability exists? Real-world data, it gives us insights into situations where the theoretical probability is unknown, too complex to calculate, or simply doesn't reflect reality, like our thumbtack. Testing predictions, it helps us test if our theoretical predictions are actually playing out in the real world. Decision-making. Businesses, scientists, sports analysts, and even you use experimental probability to make informed decisions based on actual observed events. There you have it. Experimental probability is your go-to tool for understanding the likelihood of events based on what actually happens. So next time you're curious about a real-world chance, don't just guess. Run an experiment and calculate that experimental probability. Got a cool experiment you want to try? Share it in the comments below. Don't forget to like this video, subscribe for more practical math lessons, and hit that notification bell so you don't miss out.